All right, so today we're gonna go and do some notes on page 43. Today we're doing velocity time graph. Okay, so velocity time graph. They're gonna look similar to our distance time graph, but instead of distance going on the y-axis, we're gonna have velocity. So remember, velocity is speed, how fast you're going. So we'll have time on the x-axis, velocity on the y. Okay, so let's draw some stuff, see what happens. All right, so right here, what do you think we have? Like, we see that the line's going straight up, kind of constant, it's not curved or anything. So this is someone who's getting more velocity over time. So what does that sound like? At any point, if you want to try and guess, just pause the video and try to think. But if his velocity is going up, he's getting faster. So this line is not just movement like it was on our distance time graph. It's faster and faster movement, which we call acceleration. So speed is increasing. So speed is increasing. So right here we are accelerating. And so next, let's say this happens. So on our distance time graph, that was no movement, right? They were stopped. That's not the same thing here though, because right here, time's going on, the velocity is not changing, but he does have velocity, right? Like we can imagine this is some velocity, 10 meters per second, like that, right? So here, he's not getting faster or slower, but he is moving. He's moving with constant speed. So there's no acceleration. Okay? Constant speed, no acceleration. And then we go here. So this one now would be velocity decreasing, so slowing down or decelerating. Slowing down. That's still considered a form of acceleration. The speed is changing. We sometimes call it deceleration or negative acceleration. But slowing down, losing velocity. So that's the main thing going on here on this graph. If we do, again, you need to write these in your notebook on page 43. If it's going too fast, just pause it and write it down, and then we can move on. So let's do another graph here. So time and velocity again. So now let's get two lines. We got this guy going here, this guy going here. So A, B. So what does this show? They're both accelerating, right? Their speed is increasing. They're both getting faster, but who's accelerating more? Like who's getting faster? A, right? More acceleration. Right? His velocity is going up higher than B's in the same amount of time. Like if you pick this time, B's here and A's way up here. So this person is like really hitting the gas pedal, and this person is getting faster, but like at a slower pace, okay? Which reminds me, if we go back here, let's use a car analogy to explain what's going on here. So speed is increasing here, constant speed and slowing down. So if you're in a car, this part on the graph would be like hitting the gas pedal. You put your foot on the gas pedal, hit it real hard, your speed shoots up, okay? Here, you're still moving. Like let's say here you get up to like 55 miles an hour. Here, constant acceleration. This would be like cruise control. You're moving, you could be moving fast even, but you're not changing your speed. And then here, stop sign's coming up, so you hit the brakes and slow back down to 0. So that's what this graph is showing. Car speeds up, goes to the same speed for a while, and then slows back down. So hopefully that makes it a little more clear. So going back to this graph, if we look here, so now after they accelerated, right? So now what are they doing? Well, just like we said in the other graph, if it's flat, they have different velocities, but they're going the same speed. They're not going faster, they're not going slower. They're going the same speed. But A is faster. Constant velocity. So this would be like this car is hitting cruise control, right, at 55 miles per hour. This car sped up to 80, right, and hit cruise control at 80. So they're not changing their speeds anymore, but A is still going to be moving faster. It's going to be moving farther away from B as time goes on. And that's pretty much it, right? So getting faster, constant speed. Maybe they get bored, they want to go faster again, right? So they can increase speed. They don't always have to brake. They can go the same speed for a while and then increase speed again, okay? So now that you've written these down, there's a handout. It's going to go over distance time from a couple weeks ago and velocity time, and it's on a gizmo. Play around with the gizmo and then answer the 5 questions at the end. There's 5 questions at the bottom of the gizmo. That's your assignment for today.